1, I'm looking a little bit. You can learn how to do this and take notes during class and then on a puzzle. So we're going to talk about arithmetic sequences. This is a cute pen. Arithmetic sequences. So arithmetic sequences is what you guys did in 1.2, and we're going to do lots more of them. So today's date is August, and then today's the 19th for you, 2020. So go ahead and make sure you put your date, start with notes. I'm going to change this to be a regular color pen for the rest of this. So we're going to start with a sequence of picture that was actually in your workbook that you did, and so we had this was step 1. So this was the writing set go that we just did for homework coming on Monday, and this is step 2. And then this was step 3. And so you should have noticed that if I'm going to put in this color, that this is what I had originally. So I'm going to just leave that like what I had originally colored. And then what I'm doing is I'm adding on 1 on the outside of each and then on the top. And so if I could actually color this. So here, what I'm doing is I'm adding 3. And it was on the outside of each side and then on top. And then here, I'm adding 1 on top and 1 side on the other side. And then this is what I had before. That's what I had before. Then I added the green ones on. And so then I added 3 on again. So it went that way. So I'm just going to keep adding 3 every time. So my next one, I'm going to have an added 1 on the outside. So instead of having 5, I'll have 7 on the bottom. 1, 2, 3, 4, 5, 6, 7. And so when we're 2 high from the middle, I'm going to go 3 high from the middle. So this should have been your step 4. And that's the 3 that I added on. And then my next one, I'm going to keep adding on 3. So my pattern is I'm adding 3. And step 1 was I had 1. And then step 2, I had 4. Step 3, I had 5, 6, 7, and I just kept adding 3 each time. And so this time I have 10 and 1, 2, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the next one I have, I'm going to have 3 more, so I'm going to have 13. So I'm not going to draw that, but you would just add on 3 more to the outsides. So this sequence is I'm adding 3. And so arithmetic sequences, what those are, is you're adding 3. Sorry, I gotta move this up. So I need to move my screen up. There it goes. Okay. So with arithmetic sequences, and so let's write this in this blue. An arithmetic sequence is we have a pattern that is adding, and you also could have subtracting or subtracting each step. And so in this case, I was adding 3. And so what we need to do is it's really helpful if you take your patterns and then you make a table. And so this is our figure number or our step. And this is the number of whatever it is we're talking about. So we need a step 0. So I'm going to put a 0 there. And we know we said it was step 1 is 1, and step 2 had 4 and 7 and 10, and we're adding 3 each time. So this number here, this plus 3, is our growth. So that's an important term we're going to be using a lot. That's our growth. And we're usually going to represent that with m because it's also known as your slope when you're graphing a line. But now you need to figure out what this y-intercept is. And so I need to, if I'm going down 3 every step, then I would subtract 3 and then minus 3. And so I go 1 minus 3 is negative 2. So my step 0 is negative 2, but I can't draw negative 2 blocks. So I'm not going to. I'm just going to put this y says f of 0 is negative 2, or figure number of negative 2. But again, we can't draw that because it's how do you represent negative 2 blocks. So that's an important part too. This part right here is our starting value. And so our starting value is going to help us with our equation. So the equations that you need to have, we have the explicit. Go back to my, let's go green now. I have explicit. Oops. And then I also have recursive. And these are both ways that we can represent our function. So this is an explicit equation and recursive equation. And you're going to have to get good at writing explicit and recursive for this type and another type that's called a geometric sequence. So explicit is what you've seen before. It's like this y equals mx plus b, where you have y as your slope and b as your intercept. But we're using function notation. And so we're just going to say f of x, which is the same thing, equals mx plus b. So this just means that this is the use like our y. So if I go back to my table, this is my f of x. So this is my x, and that's my f of x. It's called function notation. So when I plug in a number to this equation, with whatever this x is, it's going to go over here also. So I have, in this case, f of x equals, my m is your growth. Should put that in red. That's your growth. Looks like Christmas colors. So that's over here. That's that slope. And then B, I think I used this color. This is your y-intercept. So this is going to go all the way over to here. It's that number. So when I write my explicit equation, I go f of x equals, my growth was 3. And then I'm going to have my x there, plus, and then in this case, my y-intercept was that starting value, which is negative 2. So you might see this written instead, it'd be written as, without the coloring in them, it's f of x equals 3x plus 2. Okay, so this b value is your y-intercept, or your f of 0, that figure 0. So if they don't give you figure 0, you have to find it. So this is my explicit equation. There's only one part to it, and it's just this. It's one line. So explicit is easier, I find, sometimes. And when we get into math 2, it's actually sometimes a little bit harder to do. So now the recursive, I'm going to choose this blue color instead. The recursive is going to be what it shows the adding on, shows what we add on to get from the to get to the next figure number. So for example, so that means is that we're going to say f of x, so that's like this is the new one, or the next one, equals f of x minus 1, and this means the previous one, or the last one, and then plus your growth, and that's that red one again. So plus, I'm going to put m here. So this is your growth. Sorry, I ran out of room right there. It's not writing. Okay, that's your growth. So you also need to have, and I call it the address. And so that's going to be, you need a point also. Okay, so for this equation, I would have my f of x equals f of x minus 1. That part's always the same. Every time you do it, that's going to be the same. So, oops. Oh, that's kind of cool. Okay, so this is your this part stays the same always. And then it's just going to be what's happening. So in this case, I'm going plus 3. And then you need to have a point that we know on our table. So you could say f of 0, we figured out was negative 2. Or you could say f of 1 was 1. Or you could say any of those other points. Okay, but you need to have two things. You need to have 1, which is the equation, and 2, a point. So in order to have the recursive equation, you need to have both of those things. And I'm sure we're going to have to go over that many times. Okay, but you need to have two things there. So recursive needs the equation. And I always say and the address. Okay, so you need to have both of those there. So and this is like just a point that's from the table, from your pattern. Okay, so that is your the example for today. So again, these are in your notes. And so you can go back and rewatch this video again. And so if you have any questions, let me know. We're going to use this a lot, but these notes, we're going to help you. All right, so just have the connections that I have shown here, your growth, your y-intercept. Make sure you have what your pattern was, and hopefully this helps you. And you can ask me more questions when we come back together. All right, take care. I'll see you in a little bit. Bye.